First off, we're going to demonstrate the vertical crossing tool. This tool is used retrospectively to overcome clashes which have been found after modelling of services has been completed. It's very straightforward to use. Here we can see a list which describes the trays which are laid up in the vertical plane, which allows you to select the appropriate tray even from the plan view. Following this, we can then see the dialog in which you can detail exactly how you want the crossing to be achieved. You can see here the angle that you can choose. You also get offset limits, and here we can see that this offset is not possible due to the minimum constraint of the fittings that are required. So we can see here that it needs to be a little bit higher, or alternatively we can use a different angle. And then here we can see that using this new configuration allows the crossing to be achieved without the need for drawing sections or changing views. In the same manner as the vertical crossing tool that we've just seen, the multi-vertical crossing tool can be used to adjust multiple objects at the same time. In this example, we're going to be moving the pipes over the cable trays, but this would work just the same the other way around. But just to demonstrate that you can actually use this tool on other services, we're going to adjust the pipe work here. So again, this works in the same manner as before, except this time you actually select all of the, in this case, pipes that you want to adjust at the same time. And once you've chosen all the appropriate settings for your crossing, you can click OK, and then it will adjust all of these objects all at the same time, once again from the plan view without the need for sections or changing views. So next we're going to have a look at another example of how a similar tool can be used, but this time we're going to adjust these cable trays in the horizontal plane. So this is useful if you're coordinating with, say, steel beams, or in this case a duct. It could be drainage pipe work or just about anything. And the tool can be used again from the plan view. Everything's designed here to be used from the plan view, and this can be used then to adjust these cable trays around the object, even though the trays are stacked. So the next thing that we do here is we select the trays that we want to adjust alongside, and then we're choosing the coordination point in this case. With this tool, things work a little bit differently in that you can obviously set the tolerances and the offsets just the same, but this time it's actually going to adjust these in the horizontal plane. So we do have a switch here that you can use to change the crossing direction if needed. So if this has been created on the incorrect side, then you can just click this button and switch it over to the correct side. Again, when you're happy, click OK, and it makes the adjustment on all of the cable trays at the same time. Now, while we're dealing with these cable trays, we can see here there's an issue with the vertical alignment between these trays. So here we have a Smart Move feature. What this allows you to do is essentially adjust in the same way as you are doing with the vertical crossing tool. You can adjust where you want a cable tray to be in relation to another object, or any other object for that matter, not just cable trays. So here you can put a tolerance in, and when you click update, it will adjust the cable tray 150 mm in this case below the cable tray above it. Here we can see you can pop out a 3D preview, so if you've not got a 3D view open like I have here, then you can have a look at what this is going to look like in your 3D preview. And once you're happy, click OK, and it makes the adjustment for you like so. Now that we've seen how we can deal with clashes, we'll have a look at another common situation. In this case, we've got two cable trays which we could assume are running down a corridor. And what we want to do is we want to branch off the side of one of these, but we need to go either over or underneath the other cable tray that's adjacent to it. So here we can see we have the angle to horizontal tool, and in this case you can choose the angle that you want to use to adjust your cable tray, and then here you can set the offset. So in this case what we're going to do is we're going to use 150mm tolerance, and then we're going to use the coordination tools that we have here to coordinate this with the other object. So in this case we're going to go underneath the cable tray to the right of this one, and using the settings in this configuration tool, what we can do is create the adjustment automatically, and then from there you can continue drawing as normal. What this will then achieve is it will allow you to create this set down, in this case off the side of your cable tray, with 150mm tolerance underneath the adjacent cable tray. In this next example, we're going to see how we can use a tool to connect up these two pieces of conduit. Here we can see this piece is at one height, and then this piece is actually at a different height. So this is going to be quite a tricky operation, and here we can see this in plan view. And what we actually want to do is we want to connect this conduit into this elbow as well, just to add another layer of complexity to this. So we can actually achieve this with the standard connection tool. Here, if I click on the two components I want to join together, we can see it gives us a suggestion, which to start off with looks pretty sensible. So we can go through this list and see other examples of how we might want to make this connection. But in this case, to be perfectly honest, I think the first suggestion that we had was the most sensible. So once you've chosen a suitable connection, click OK. And once again, the operation is all completed from the plan view. In this example, we're going to see a practical use of the angle to horizontal tool. So in this case, we're going to use the tool from the end of this cable packet, and we're going to use this to essentially draw this cable packet in a coordination with the cable tray that we want it to represent. So here we can see we're using the alignment tools to adjust this in line with the cable tray that we're following, and once you've selected the offsets as required, we can see that this now sets up to the required height. At this point we can continue drawing as normal, and it's important with cable packets to note that you can't connect these to other objects, so it's always sensible to turn off automatically connect feature. And then in this point we're actually going to use the angle to horizontal tool from the drawing toolbar here to adjust this back down to its original height, where we can continue drawing the cable packet around the cable tray as needed. As well as the coordination tools, MagiCAD also includes advanced drawing tools, which in this case we can see the cable tray here has a electrical system. You can also choose communication and data systems, but in this case we're going to draw this as a power system. And this is quite different from out-of-the-box Revit, in that obviously you can choose a system as you would with pipework or ventilation, and then choose the appropriate type and size of tray. And then in this case you can see we can use this height to the bottom of the tray here to coordinate where we actually want this tray to be drawn. We can draw this in plan view like so, and then using the angle to horizontal tool that we saw earlier, we can then adjust the height, again all done from the plan view. And if I click OK, we can see it draws the setup in for me there. I can then draw this along, and then again I can use the angle to horizontal tool here to adjust this back down to its original height if needed, like so. So rather than using the coordination tools, you can just type the offset in if you know what it needs to be. So as you can see, it makes it very easy to define which systems you want your cable tray to be on, and also to adjust the height while you're drawing as well. Now, in some cases, it can be very difficult to coordinate your tray work. So in this example, we're going to see how this tool operates in the 3D view. So here we have a cable tray that we're drawing in 3D, and we can see here this is drawing in one particular plane, and this is dictated by the various axes that you can see here, and you can switch between those by pressing keyboard commands. And in this case, I'm going to draw a segment of cable tray in the Y direction, and now I can choose this angular offset here, which allows me to coordinate this again in the 3D view. I can actually type in the length and angle that I want to create this at, so I can type 1000 at 45, and it will draw a segment in that's 1 meter long at 45 degrees. And then again, I can use the functions here to change the direction of the tray and draw quite easily within the 3D view. In addition to the enhanced modelling tools, MagiCAD's intended to enhance the design capabilities of Revit and add value to the overall platform. In this example, we're using a tool to link spaces to switchboards, allowing us to define which areas are served by specific distribution boards, with the phases that the spaces should utilize. Also, we're going to use this to estimate the power required in each space and for the building as a whole. The design parameters that define the power that the spaces are going to require actually come from Revit's MEP settings under the building and space type settings. We can see an example in this schedule of what these power densities could be. In this case, I'm using the space types to define the power density for the lighting and power in each space. I can also define in here a fixed load, which is actually a MagiCAD parameter that allows me to add an additional fixed load on top of the power density. With all of these loads defined, I can then push that information through onto the actual switchboard itself. Here we can see the estimated load on this board. On top of that, we also have a diversity factor and allowance for future expansion as well. So this allows our calculations to be quite accurate. Additionally, any connected boards will also push the information upstream. So here we can see the total estimated load with the diversity from the main switchboard. This will then provide the overall building demand. One of the more time-consuming factors of MEP design is recreating models in third-party software in order to perform industry-compliant calculations. MagiCAD improves this process in this case using our Dialux Export-Import tool. By selecting the spaces you wish to model in Dialux, the tool will export these spaces and reduce the amount of modeling required within the Dialux platform. Once the spaces have been exported from Revit, you can then import those spaces directly into Dialux. Once the file's imported, you'll be able to see the geometry as exported from the Revit spaces. This geometry also includes data from the spaces. This includes things like ceiling, wall and floor reflectance, as well as the work plane height. Unfortunately, Revit doesn't include a wall zone, so this would have to be included manually. Once all of your conditions are set, you can insert luminaires and calculate the project as normal, getting the results and the outputs that you normally would. So at the point where you're ready to replicate the results within Revit, at this point you can then export your project. and save that file so that it's ready for import. So with this freshly exported file, we go back into Revit, go to the Dialux import dialog, and then select the file that we just exported from Dialux. Now at this point you can choose whether you want to bring the information in from all of the spaces, or in my case, just one space. This is really handy for change control. Here we can see it's asking us for a little bit more information. So the information that it has from Dialux takes it so far, and then we just need to put in a little bit more data just to get this ready for use within Revit. And once we're happy, we click Insert, and at this point Revit will then put those files together and create these Revit families. So these Revit families can be used just like any normal Revit family. You can create circuits, detail them as you normally would, but these are converted from the Dialux families themselves. When selecting the products you want to use within your project, MagiCAD uses its own internal data set, which can be seen here. You can of course add products to this data set. It's quite a straightforward process, and these products can be added either from third-party Revit families, or you can browse the MagiCAD Cloud. Here we can see an example of selecting a new product from the MagiCAD Cloud and how we import that into our data set. You can see the details of the product within the cloud itself, see all the dimensions and what the family actually looks like. And if you're happy with that, you can insert that into your data set, at which point you can detail anything that needs changing. And once you're happy with any of the changes you've made, you can then save that product for use later on and insert it into the project. When you're ready to insert a family into your project, you can choose between whether the family should be level-based or face-based. This is a one-time choice for each individual family, but families can be duplicated and changed appropriately. Here we can see the offset where we want to install this. There are different measurement points for this, so you can choose the appropriate offset for the installation point. And in this case, we're going to use an array installation, which is arraying within the actual ceiling grid itself. So in a reflected ceiling plan, you can view the ceiling grid, you can choose the base points that you want to use and set the distances between the objects. This can be seen again here in a larger room, and once the base points have been selected, the tool knows how big the ceiling tiles are and what orientation they're in, and then it can array the luminaires appropriately. A number of product categories within MagiCAD can utilize something that we call an operation area. So here we can see a smoke detector, and this is using 3 operation area rings to show the operational range of the device under different conditions. So here we're going to use the array tool to assist with positioning these products, and we can see here we've got full coverage of the space with these 4 detectors. Once we click apply, it's going to trim the operational rings down to the extent of the space, making it a lot neater to view this in busy areas. As you can see here, this drawing can get quite messy very quickly, and trimming these down to the extent of the space really helps with keeping things legible. One of the latest offerings within MagiCAD is the Connection to Mechanical tool. What this tool does is it provides a convenient and easy to use connection with mechanical equipment within the model. This then allows you to add the mechanical equipment to your electrical circuit and therefore pull in all of the details of the circuit from this. As we can see from this example, here we have an isolator, and currently there's no load attached to this circuit. So what we can do is we can edit this circuit And in editing the circuit, we can add this pump, in this case, to the circuit. And once this is added, we can now see that the load has transferred through. When creating circuits within Revit, it can often be difficult to manage those circuits. Here we can see we're creating a Revit circuit, but beyond that, the actual management of this circuit is quite difficult. Here in the Manage Circuits feature, we can see the details of the circuits that we've created, and we can also see that they're numbered differently to how we would want them. Here we have a tool that allows automatic numbering of circuits based on particular rule sets. These can be changed and modified as required to allow you to detail the circuits as necessary. Additionally, the properties of these circuits can be changed using the Set Properties tool. Here we can set the cable type that we want to use within the circuit. We can also utilize the installation method. We can set the type of circuit, and then this infers a number of other pieces of information which are detailed again in the data set. Here we can set the rating of the circuit as well, and once that's updated, we can see that that's transferred into the project. Once you've detailed the information within the circuits, you can copy that information through into a switchboard schematic using the Manage Links feature. To utilize this feature, you can select the appropriate places where circuits should be within your schematic and link those circuits like so. Once the circuits have been detailed, you can see them in your switchboard schematic like this. You can also update the information from the project onto the schematic by using the Update Circuits feature. This will then provide you with a list of all of your circuits and all of the details to go with that circuit, and therefore allow you to build a calculation based on this data. One of the issues that you can experience when detailing circuits within Revit is correctly assessing the lengths of the circuits. Within the MagiCAD electrical module, we do provide you with a method of assessing these cable lengths, along with producing other data as well. We call these cable packets, and what these are is a modified conduit type, which allows the connection, as you can see here, of circuits to the conduit. And what that then does is it traces the circuit back and gives you the overall length of the circuit. And not only that, but it also produces other information, like here we can see the cable type. And if I update some data within the model, I can also get this to show me the circuit IDs that are also connected within each segment of this cable packet. So the cable packet can represent the overall route of your containment, and within each segment of the containment, you can see how many of what type of cable there are, which circuits are there. You can also produce other information like the weight in kilograms per meter and the overall laid up diameters of all the cables put together. With this information, you can accurately size your cable trays, and you can also perform a QA process whereby you're checking that all of the circuits are on the correct routes. And then finally, within this circuit, we can now see we've got the supply cable length detailed here. Once you've finished calculating and detailing the circuits within your Revit project, it's time to display this on an output drawing. Traditionally in Revit, this is quite difficult to achieve, especially if you're using wires to demonstrate circuits. Here we can see that MagiCAD provides a wire tool, and by choosing various different options, this allows you to configure exactly what you want the wires to look like, and therefore how to detail your circuiting properly. We can see by the use of this tool that it's quite straightforward to use even in a manual process, and it's certainly a lot faster than using out-of-the-box Revit tools. Once these are input into the model, they are simply Revit wires and can be adjusted as you normally would. You can also detail other items. for example, in this case, leaders. So to detail the switching within your circuit, you can use the same tool to produce leader lines. You can also tag these wires to show your circuit numbers. There are a number of MagiCAD tools which are used to detail this information, and here we can see the MagiCAD tag tool. This tool utilizes the standard Revit tag feature, but provides an override and allows you to select the correct tag for each individual type of product. On top of the manual wire drawing tool, MagiCAD also includes an automatic wire drawing tool. This tool allows you to draw the wires for a complete circuit in one click, providing efficiency and speed along with accuracy. One of the more challenging situations in Revit is detailed in this example here. Here we have 5 products which are all grouped together. The 2D symbols for these products overlap one another, and also we can only see 3 symbols in total. Here we can use the symbol organizer tool to detail exactly how we want to display these symbols and then arrange them without affecting the 3D geometry.